Welcome to this video. In this lesson, we'll be solving some questions on principle of moment. So before we get to the solving of questions, let's first know what principle of moment is. Principle of moment states that for a body in equilibrium, the sum of the clockwise moments about any pivot point equals the sum of the anticlockwise moments about the same point. So if we were to express this principle mathematically, it means that you have the forces acting in the clockwise direction on one side equal to the sum of the forces acting in the anticlockwise direction on the other side. So now, at least we have an understanding of what principle of moment is. Let's now get to the solving of the questions. The following diagram shows a uniform 4-meter wooden rod pivoted at its midpoint. Four forces are acting on the rod to keep it in equilibrium. What is the force F? So we have a wooden rod, and then there's a force F, which is unknown, which they're asking us to find. And then we have other three forces which are acting on this wooden rod. So let's first identify if these forces are acting either in the clockwise direction or in the anticlockwise direction. So the force F, let's start with the force F. This force F, it is acting in the anti-clockwise direction. And then the force 20 Newton, this is acting in the clockwise direction. And the force 30 Newton, this one also is acting in the clockwise direction together with the force 20 Newtons. We have the direction of these forces in which they're acting in. And then let's identify the distance from the pivot to each force which is acting on the wooden load. So the wooden load is said to be pivoted at its midpoint, and this wooden load is 4 meters. So it means that at the midpoint, at the pivot there, from the force F, it is equal to 2 meters. And then, so from the force F, from this force F to the pivot, it is 2 meters. And then from the pivot to where we have the 20 newtons force, it is also 2 meters. And now let's apply the principle of moment to solve the value for F there. So we have F1 D1 equal to, so F1 will be the force F, and then the distance 1 will be the force from the pivot to where we have the force F, and then F2 will be the 20 newtons force, and then 1.5 meters will be the distance 2. And then we have 30 newtons here will be the F3, and then the 1 meter will be the distance 3. And then we also have 20 newtons. So this 20 newtons will be the F4. And then its distance from the pivot will be D4. So let's write F2 D2 plus F3 D3 plus F4 D4. We can now replace what we have. So the F4, the F1, we said it is F, and then the distance 1, it is 2 meters. So we can write 2F equal to the F2, we say that it is 20. So we can write 20 and then multiply it by 1.5, which is the distance 2. and then plus the F3, it is 30, and then the distance from the pivot, it is 1 meters, and then plus the F4, we have it as 20, and then the distance, it is 2 meters. So we have this. We can now calculate. Let's multiply the 20 with 1.5. If we do that, we'll have 30, and then plus 30 multiplied by 1, it's still 30, and then 20 multiplied by 2, you have it as 40. So if we add these, it will give us 30 plus 30, that is 60, and then plus 40, you have it as 100. And then we can write f, you can write 2f. So we can now divide the 2 on both sides so that we can find now the value of f. So if we divide by 2, so this 2 and this 2 can cancel out, and then the value of f will be equal to 100 divided by 2, it is just 50 newtons. So 50 newtons is the value for F there. It is the force F that we have been asked to find. So we have answered this question. We can now move to another question. The following shows a uniform meter rule in equilibrium when different masses are hung on either side. Calculate the value of x. So this value of x, they're asking us just to find the other mass which is on the other side here. So in order to find the value of x here, which is the mass, we need the distance from the pivot to where we have the mass, as well as from the pivot to where we have the other mass, which is 20 grams, and then from the pivot as well to where we have the other mass, which is 10 grams. So now we can let's label these. So this one can be F1, and then the 30 centimeters can be not F, so we can just mass 1. Since we are dealing with masses, let's label them as mass 1. And then this one can be distance 1. And then the 20 gram can be mass 2. And then where you have 10 centimeters, this one can be distance 2. And then the 40 centimeters will be our distance 3. And then the last one, the x, this one can be the mass 3. We can say F1 D1 plus F2 D2 are equal to F3 D3. So now where we have the F1 there, we can replace, since F, it is just a weight, it's a form of a weight. Where there's F, it means that we can replace M1 and then the acceleration due to gravity, which is g, and then multiply by d1, and then plus, while there's F2, we can replace with m2 g and then d2, and then equal to, while there's F3 there, we can replace with m3 g and then d3. So let's at this point we can factor out a g on both sides of the equation. So let's factor out a g. So g on this side, what will remain is m1 d1 plus, factoring out a g here, again it will be m2 d2 being equal to G, and then M3 D3. So now we can cancel the G on this side and the G on the other side, and what will remain with is just M1 D1 plus M2 D2 equal to M3 D3. So now at this point we can get the data that we have on top there on the diagram and replace with what we have in this equation. So at M1 we can replace with 10 and then multiply it by the distance 1, which is 30, and then add M2, you have 20, and then we can multiply it with the distance D2, which is 10, and then equal to where we have M, which is X there at on the other side, so we can replace with X and then multiply it with 40. So let's multiply 10 and 30. 10 multiplied by 30, you have it as 300 plus 20 multiplied by 10, you have it as 200, and then equal to 40x. So 40x, let's add the 300 plus the 200, it will give us 500. At this point, since we want to find the value for x, we can divide 40 on both sides. 40 into 40, it will cancel out, and then we'll remain with an x. So therefore, if you divide 500 by 40, you have a value as 12.5 grams. So the value of x is just 12.5 grams.